What sort of magic is behind the fact that when you are doing update or delete operations, your database is not growing out of size? So you are not losing all of the space on your physical drive if you have database locally or on your server. What is happening behind the scenes that this, in fact, is not causing any sort of problems? Hello friends, welcome back to the channel, and in today's video we are going to tackle the vacuum operation, and I'm going to explain you how this operation works, how the database is being cleaned up when it comes to the delete and update operations. We will also cover MVCC operations, how does it affect exactly the vacuum operation, and we will check it on the real life examples in the database. But before we will jump into the action, a bit of theory, so stay put, let me go through it. Okay, before we will jump into vacuum operation, let's start with just the brief introduction, or maybe just the recap from my previous video about page layout. You can check it right here, it will be attached, about how exactly the data is structured in the database, right? So you have your table, let's say products, right? And you have some products saved into this table, but how actually it is being stored inside of the storage itself. So you know, or you will actually get to know right now, that the data is being stored in the pages for the database, right? And the page has its structure. Among others, let's not get into the details right now here, but among others, it has an item identifier array. That is basically a pointer to the information, physical location of the item data, and the item tuple itself. And what is the tuple? Tuple is basically a record from your table inside of the database. As you can see on this exact picture, you see that, for instance, item ID data array 1 with the red is pointing to item tuple 1, 2 is pointing to item tuple 2, and 3 is pointing to item tuple 3, right? Now, having that in mind, I would like to introduce two concepts to just go further before we will jump into the vacuum. First concept is actually the fact that we can have row-oriented storage. So when we are loading actually the data from the table, it is being loaded into the space called basically buffer pool, right? And in case of online transactional processing databases, OLTP, we are loading whole tuples, so basically whole records into the buffer pool. This allows such databases, OLTP databases, for extremely fast insert, update, delete operations, as basically we are almost in all of the cases operating on whole records, whole tuples inside of the database, right? So in case of loading the product tables mentioned before, we rarely want to just load the ID of the products. We most likely want to load the name of the product, the code of the product, description probably, maybe the state, how many we have in the warehouse, etc., right? So it's basically will consist out of whole information from the product table, all majority of the information from that product table. So basically, in row-oriented storage, it is important to remember that we are loading whole tuples into the memory when we are querying the database. In contradiction to the row-oriented storage, we have column-oriented storage, the OLAP, online analytical processing, basically structure. And this is extremely efficient for analytical queries, such as when you want to calculate averages, for instance, of your, I don't know, age, in this case of the example from my slide, or in case of products table, when you want to calculate the warehouse stocks of your products, right? In that case, a particular database that is leveraging column-oriented storage doesn't need to really load all of the records from the tables to calculate that one, but is actually loading separately information from a particular columns, like from age, name, and ID, right? So if we want to count the occurrence of Alice or Bob, you will just use this name column. And if you want to count the average age, you will just use this single column age loaded into your memory. That is extremely efficient for analytical data, right? Why does it matter, right? It matters because right now when we are going to talk about that tuple, we will concentrate mostly on the fact that we will be working with OLTP systems. So we will be actually loading whole records into the buffer pool. And what exactly is a dead tuple, right? So you know that the tuple is basically a record from your table, table like products, etc., right? But what is happening when you are doing update or delete to a particular record? In the example from the slide that I've prepared here, take a look at the ones marked with red, number 1 and number 4. So initially in our, let's say, product table, we have a record 1, right? It has some value like the product name, for instance, product ABC. But by some reasons, we want to change this product name from ABC to CDE. In that case, new record is being added to the table behind the scenes, but the old record with the ID 1 is not being actually automatically removed from the table because it might be used in case of some transactions. Think about it in that way. You have some pretty big query that is running, that is actually leveraging all of the informations from product table. I don't know, maybe some sort of aggregations, maybe some sort of monthly statistics, right? But this is a big query that will take some time to run, right? And in the meantime, someone else, another transaction, actually want to update the product information, the one that we've set, so from product ABC to product CDE. In that case, I will be talking from the Postgres perspective, but majority of the databases have the same actually concept. In that case, something that is called MVCC is being introduced, multi-version concurrency control. What does it mean effectively? It means that for the select operation, when you are actually loading all of this data from the products table for your analytics query or whatever that is taking this long time to process, the state of the table from the start of that actual processing will be taken. But on the other hand, we don't want to block other transactions to be issued against products. So the update or delete operation will be actually executed on the table. So at the end of the day, to have everything compliant, consistent, etc., the identifier 1 will be marked as a dead tuple, and identifier 4 will be actually the one available for the further processing next selects in other transactions, right? So this is important to understand. This is actually the concept that the readers should not block the writers, and the writers should not block the readers, right? So if I just want to read the state of the table, I shouldn't be blocked by a writer, and when I'm actually writing something to the table, like I'm doing an update or delete operation, I shouldn't be blocked by a reading operation. And in that case, in case of such operations, we are talking about dead tuples, right? So having this dead tuples, right? So you can see that instead of having just 3 records in our page, right? 1, 2, 3, we have 4. 1, 2, 3, and 4. Out of which, number 1 with identifier 1 is marked as dead tuple because of this one transaction that is still using it and the second one that has changed it. So for how long does this record stays like that as a dead tuple? Does it stays indefinitely, taking all of the space that you have on your storage, or there is some sort of mechanism that is actually cleaning this up? And of course there is. It's basically called vacuum. This is actually the representation from the Postgres documentation, where you have all of the options. I'm not going to go through these options right now, but please keep in mind that each and every single database has similar concepts. If it's not named vacuum, maybe it is called garbage collection, etc., right? But there is some sort of mechanism that is cleaning up your database for you from these dead tuples, right? And what vacuum operation does? It basically checks pages of your database for the dead tuples and automatically is cleaning them up as long as they are not actively being used, they don't need to be used anymore, they are not being logged by any transaction, etc., right? And this operation by design, in case of PostgreSQL, is being done automatically. In a SQL section, in example section, I will go through with you how this actually is being done. But this operation is being done automatically. You can of course disable this automatic vacuum operations, although I don't really recommend it unless in some specific cases that you need to disable it in terms of performance or in terms of some operations that are happening on the tables to not trigger auto vacuum. But in general, the vacuum is being done automatically, but also you can call it on demand using the vacuum operation command. What you need to just remember about the vacuum is that you need to have, from the Postgres perspective, right? In other databases it might differ, but from Postgres perspective, you need at least maintain privilege on the table, right? So with just read-only user, you will not be able to leverage that SQL command. Next. Vacuum operation cannot be executed inside of the transaction block. So it is a standalone operation for your particular table. Next one. It's not actually a standard SQL operation, right? So if you will open the ISO documentation for PostgreSQL, for SQL language, you will not explicitly see there a vacuum operation, but again, check your database of choice. Each and every single one of those, as far as I know, supports this kind of operation, like the vacuuming, removing dead tuples of operations. And it might be named vacuum, it might be named in other way, but still, you need to remember that it's not part of a SQL standard per se. So, for instance, if you are working, I don't know, with Snowflake, or if you are working with MySQL or Oracle, it might be named differently. It might behave slightly different, but the concept behind the scenes still stands, that there is a mechanism that is basically cleaning up your data. And one last point, the critical one, the vacuum operation is basically causing a substantial increase in I/O traffic on your database, and it might lead to poor performance. So if you have especially big tables and you do plan to execute the vacuum operations on those, please execute them carefully, especially not when your clients are actively using those tables or other services or other operations, because it may lead to some bottlenecks, performance hiccups, and some problems with general your application. So use it carefully. Auto vacuum, on the other hand, is taking a bit different approach, but with vacuum when you execute it yourself, it's a bit different thing. Okay, we have the theory covered. Thanks for staying with me. Now let's get to the examples and nitty-gritty details from the SQL perspective. So let me change the view here. Actually open the SQL. So let's start with how actually we can check what is enabled in our database. And this will be, please remember that this will be from the PostgreSQL perspective. From your database of choice, the comments will be different, but still I would expect that there are settings that are actually providing you the information how actually it is being handled in your database. So, in case of Postgres, right, I'm using PG settings table and I'm looking for the name containing vacuum. And I see that, for instance, auto vacuum operation is on, right, by default. So my database, all of my schemas, all of my tables inside of the database will have an auto vacuum sub process running. So in case of delete operations, update operations, I don't need to manually run vacuum operations. It will be handled for me automatically. For the sake of this exercise, we are going to disable this setting for a particular table to show you how actually the dead tuples are being stored. But in general, you need to remember that for Postgres, auto vacuum is by default on. And you have tons of different options. We are not going to go through all of them right now, it's not needed. But as you can see, it's not like one setting, just switch it on or off, and that's it, right? So you can adjust if you need these kind of informations for a vacuum or auto vacuum. But again, do it carefully, read exactly what these settings are doing, and think twice before you will change any of that one, because from my experience, it's rarely needed to adjust those default settings. I'm not saying that you don't need to do it and you shouldn't do it. I'm just saying that please think twice before you will do it actually, right? Okay, to the vacuum itself. Let's create a simple product table that I've been using in the example from slides. Again, product name, code quantity, some dates, okay? and I'm going to add there 1 million records into that table, okay? Just for the sake of the exercise. So let's check if there is something there in my table from DC products, okay? Awesome, so there is some information there. Now, when we will check the information for the products table, we see that there are no additional options besides the default ones. And as I've said at the beginning, the default option for all of the tables is that auto vacuum will be on for them. So you can disable auto vacuum for a particular table when you are creating the table, or when you actually already created the table, you can use alter table set auto vacuum enable false command and toast auto vacuum enable false, so that this will basically lead to disabling auto vacuum on your table. And in that case, you will see additional parameter here when it comes to PG class, your relational name products, auto vacuum enabled false. Now, I'm going to add to my system an extension called TSM system rows. And this extension, you don't need to do it actually, but this is easier for me to show you when I'm going to delete some rows. The concept behind this extension is quite simple. When you want to take like a random sample from your data, from your table, like, I don't know, 1,000 records, 5,000 records, whatsoever, right? There is an option to do it with table sample, but this table sample is actually taking you the percentage of the table. But if you want to take, for instance, X number of records, this extension would be actually beneficial for you. You don't need to do it. You can also use, for instance, order by random and limit. That's also possible, but in this case, that's just, you know, something that will make my life easier. Okay. So how the extension works? So basically, you are doing select from your table, then table sample, and then you have your extension system rows. And here I'm saying that I want to just select 5 records, right? If I want to do it differently, just do limit 5, that would be also okay, with some sort of order by, that if you want to take them randomly, not from the top to bottom, but still it's just for my sake of the exercise. Okay, so what I'm going to do next, I'm going to actually delete 50,000 records from my table. But before I will do it, I will show you what the structure of the table is right now. So you can see that the products table is 80 megabytes in size, without any wasted size, table bloat, etc. Let me analyze the table, because you see that the statistics are missing, okay? Let's check again. Okay, so we have right now the stats, we have some wasted size, it's small right now, but what will happen when I will delete this 50,000 records, okay? So I've deleted the records, fine. Does anything change in my table statistics? Nothing. If you will go to pgstat all tables and execute your product's relational name, you see that there are actually 950,000 live tuples and 50,000 dead tuples, which actually is a perfectly valid case, informing us that we've deleted this 50,000 records. So why it is not reflected in the statistics of the table? The answer is quite simple, because we haven't refreshed the statistics. So let's get into the analyze DC products and let's check the stats again. And you see that right now, wasted size is 11 megabytes. So basically our 50K removal of the information increased the waste size by the factor of, I think, almost 11 megabytes. There was something when we started wasted size, but yeah, in general, you see the difference here. Now, your question should be, okay, Chris, but how can I check actually those dead tuples? Is there a way to check those dead tuples? And there is an option to do it. No, not sure if I will be able to just grasp it, because I haven't prepared the query to go through looping through the pages, and there is quite a lot of the pages for that table, but let me try, right? In the previous video where I was explaining page layout, again, I will link it probably somewhere here, I've introduced you the page inspect extension for Postgres. And with page inspect, you can actually inspect each page for your product, okay? So you have all of the informations that there is a page, etc. Okay, and what is important for us is that this txmax parameter, because this flag is informing us that there was a change with this particular information in that particular table. It could be either update or delete, but in general we are going to look for the information that this txmax has changed. So let me just try to take, for instance, the page number 1. It's not there. Maybe let's do like number 3 or 2. Now this will be a roller coaster. Okay. Yeah, finally I got it. So on page number 10, I see that there are some informations, 98 tuples, 98 records that are actually being deleted. So it's not, of course, those 50K, because there are spanning across number of pages. But in that way, you can see that this table has the tuples, not only using the statistics, but actually you can check which particular record is a dead tuple if you need it. And this is the way to do it. Now, we've disabled auto vacuum, right? So the table is not being cleaned automatically right now. So if I will just delete once again 50K and once again 50K, we will see that in terms of the dead tuples, the number of dead tuples will increase to 150,000, which is expected. We've deleted 50K 3 times. And the number of live tuples also decreased by 150K. Awesome. Table stats, again, not reflected right now because we haven't analyzed the statistics. Let's do it right now. And you see that the 150K deletes increase the wasted size to 18 megabytes. So basically, unnecessarily, for the time being, we keep on our storage 18 megabytes of data because it's not being actively used. We wanted to delete it, but because of the fact that we don't have auto vacuum on, it is not being cleaned up. So let's execute the vacuum operation, right, on this table. How does this affect the basically products table? And you can see that we got back to this 6 megabytes of wasted size, not fully still. So we've refreshed the statistics. Let's check this one here right now. Okay. And let's move here and get back here. Now it's basically set to 0. So in this case, stats needs to be refreshed, although in the table size, you already seen that the page size was reclaim. So if I will right now go here and get to my query back, this 10 pages, you will see that this is basically, this provides me no information whatsoever because those records were deleted. And this is actually everything that I had prepared for this video with the vacuum. Please, the most critical information for you to remember is that there is no magic happening behind the scenes. When you are doing update deletes, you might create dead tuples because they are actually might be used by different transactions that you are not aware of. And the mechanism behind the scenes is vacuum or garbage collection or whatever you prefer, whatever would be your database preferred naming convention for this one. But those records are being removed automatically in case of Postgres with auto vacuum on, or if your database does not support automatic vacuuming, then you basically will need to do it manually using the vacuum or other operation that is reflected on your database. In case of any questions, please feel free to reach out. Thank you for today and see you next time. Bye bye.